morning, ladies and gentlemen. John Belkowitz, Intelligent Concrete. Got an early morning this morning, getting some stuff out for some of our clients on social media, getting some articles together, some exciting stuff. Wanted to talk to you this morning about using high-range water reducers for self-consolidating concrete. Spoke to one of my buddies, Friday last week, was at the airport picking up mom, and got there a bit early, and I was talking to him about this new committee to get after SCC, self-consolidating concrete, and getting people more used to testing it, and really just getting the information out there, the education. And then it just happened to be that I got a text message, or not a text message, a LinkedIn message from one of my buddies, asking me to review some pictures about an SCC, or a highly fluid concrete, and some problems that they were having. So, when it came down to it, that issue that he was having, and a lot of issues that we see on the job site, deal with overdosing of the high-range water reducer. Not all of them, but more often than not, it's this overdosing. Now, what is overdosing? First of all, the high range, it's when you're using more than what is intended for the design. So let's say you had a design of a 28-inch, 30-inch spread. You had a concrete with 608 total pounds of, or pounds per cubic yard total cementitious, 0.37, 0.35 on the water cementitious, and then you had 5767 at 1450, a 3/8 pea gravel at 350, and a concrete sand at 1250. Your high range is at 8 ounces per hundredweight, and you have an air at a half an ounce per hundredweight. The overdosage does not necessarily need to be caused by the admixture that you're putting in there. And what I mean by that is that the overdosage, again, is just getting or using more of the high range, or using more of the high range water reducer than what is needed to get the intended result. So our intended result's a 28 to 30 inch spread. If you add more water to that 8 ounces per hundredweight, if you go from a 0.37 to a 0.40, you definitely don't need as much of that high range. What ends up happening is you see this. First thing is it could either be one of these three things, and a whole bunch of infinite amount of possibilities. But this waxy film on the surface, it's almost like this splotchy lightning. And as your overdosage gets worse, or as you put in more water, that waxy appearance is going to get even worse. The next thing that you'll notice, especially if it's extreme, is this pulling away of the paste from the aggregate, either the sand or the rock. It could be dropping out if you're putting it in a container or in a form, and it's called segregation. And then the other piece of it is something called a halo. When you're doing the flow test, whether you're doing the J-ring or the inverted slump cone, if you're just using a slump cone, you end up getting this pancake, right? And at the edge of the pancake, you'll see again this, it's called a halo, but it's this ring around your spread that has, again, this waxy appearance to it. And if you have some fly ash in there, you can also see some of the carbon pulling out of the fly ash. So, let's see, sensitivity to water. So the biggest thing is that when you're using high ranges, you're going to increase the sensitivity of water, or you're going to reduce the robustness of the mix, especially with the addition of water. And there's a rule of thumb that says, with the standard concrete, for every 1 gallon of water per cubic yard of concrete, you increase your slump by 1 inch. Well, when you use 8 ounces per hundredweight, that same addition is like a 2 inch or a 3 inch, or just pushing out your spread that much further, gain in your slump. So the question is, when this does happen, what is the fix? It's not about the failure, it's about the recover. Find the opportunity in every obstacle. So what to do? First of all, don't panic. The great thing about adding too much high range is that it has a tendency of putting the concrete to sleep. So you could have a little bit of running room here. That your slump life, the amount of time that your concrete's in that dormant phase, is more than likely going to be longer. And again, this is assuming that it's a high range water reducer. So if you're out of the plant, you've got a lot of options. I think the first one would be getting back underneath the central plant mixer and throwing another yard or a half a yard, if you have room, of dry right on top of it without any chemicals. I mean, if your sand is really, really wet, I wouldn't throw the sand in there. But if you got some dry rock and, of course, your Portland cement, throw another half a yard on top of it to dry it back is definitely my first approach. The second thing you can do, there are chemical additives out there that can kill slump. I'm trying to think of a few companies that make them. The only one that comes to mind is Fritz Pack, and they come in cornstarch bags. Close your eyes and throw it in there. Another thing that you can do is either stop the mixer or spin up the mixer really, really quick. And the two theories are, and I've seen both work in different climates, different environments, and with different mixes. But the concept is, if you stop the truck, you're going to a certain degree gel up that concrete or make it stiffen a little bit, which hopefully counteracts some of the issues that you're getting with overdosing. And with the other piece of it, with spinning up the mixer really quickly, it's almost like you're trying to heat it up and trying to get reaction going, or at least trying to cook off some of that water or beat it up a little bit. And I've seen both work in the past, and it's really up to the environment, the people working with the mixer, the type of mix that you're using. And in some cases, the unfortunate reality is you got to kill the mix and figure out what the hell caused the problem. Did the driver not backspin his drum to get the water out? Was there a water valve that just didn't shut? Are we using the wrong type of high range? Are we using too much high range for the mix that we've designed? Is our moisture gauges off? There could be so many things, and each concrete technician has their ability to identify where that's coming from, and that's in their fresh property tests they have out in the field, and then also their batch tickets that they get from the ready mix plant. So I hope this answered any questions that are going on out there. Remember, if you got any questions, concerns with concrete, shoot us a message, post, like, whatever, on LinkedIn, Facebook, Instagram, YouTube. We've got a bunch of videos out there on high range water reducers. Don't forget, we are the concrete experts. Go concrete, beat asphalt.